Hello, Algebra 2 students. Today we are going to do section 2.5, model direct variation. We say that the equation y equals a times x, I call it the ax equation, represents a direct variation between x and y. In the equation above, we say that y varies directly with x. A is the non-zero constant, which is called the constant of variation. So it's a number, a fraction, a decimal, an integer, a whole number, any non-zero constant. Let's do an example. Given a point, write a direct variation equation that has the ordered pair 2, 5 as a solution. So since it's a point, we're going to label it x, y, and here are the steps. Step 1, find a, because we want to know what the constant is. Step 2, plug in or replace a into y equals ax. You only plug a into the equation, nothing else. So I'm going to label my steps. So step 1, let's start with my direct variation equation, y equals ax, and I will replace y with 5. I will not replace a with anything because we're trying to find it, and x is going to be 2, because this is x, and this is y. So it's a times 2. So 5 equals 2a. Divide by 2, divide by 2. A equals 5 over 2. That is not our direct variation equation. Our direct variation equation is going to show a relationship between x and y. So y equals 5 halves x. Replace only the a back in, and that was step 2. And then we are going to graph that. So let's say this is our coordinate plane, and you only have the first quadrant. So this is 0, 0 right here. So you are going to rise 5, run 2. So go up 5, right 2. 1, 2, 3, 4, 5. And then connect the 2 points with a line. And that's how you would graph a direct variation equation. And you can extend it out if you want to. Right. Next example. Write a direct variation equation that has the ordered pair 3, -6 as a solution. So x, y. We're going to do several just so you get the hang of it. So this time I won't write down what steps to do, but I will still number this process. So step 1 is start with our direct variation equation. Step 2, replace y with -6, a with nothing, x with 3. So -6 equals 3 times a, divide by 3. Don't divide by -6, divide by 3. And so a equals -2. Okay, in step 2, replace that a into your equation. Y equals -2x. And that's our final answer. We're not going to graph that one. Okay. Let's do a next example. Write a direct variation equation that has the ordered pair 2, 1. So y equals a times x. Y is 1, a is nothing, x is 2. 1 equals 2 times a. Divide by 2, divide by 2. A equals 1/2, not 2. And step 2, replace that a into the ax equation. Please don't write your fraction bar as a diagonal. Make sure it's a horizontal, that this is horizontal. If you do it as a diagonal, you'll see that it just doesn't look as nice. You'll end up with the x in the denominator when x always belongs in the numerator unless it's actually in the denominator. Okay, given a point and solving. So here we're given x and y individually, and you need to write your direct variation equation. It's basically the same as above, it's just not written as an ordered pair. So if x is 6, y equals -8, you can write it as an ordered pair because they are in order. You could totally do that, and then you just do the problem, just like we did above. But there's one additional step, and that additional step is oh, having issues here. So the second step is find y. Ooh, that's terrible looking. I don't know what I did, but there we go. Just leave it alone and just underline it. That might be better. Then find y when x equals 3. So now let's do the problem. So we can number the steps again since habit is great. Y equals ax. Replace y with -8, a with nothing, x with 6. -8 equals 6 times a. Divide by 6. Divide by 6. -4/3 equals a. Always remember to reduce your fractions. So in step 2, replace that. Y equals -4/3. And remember, only one of the numbers is negative, x. And then finally, there's an additional step. So this was one of your questions. Write an equation. So you would get a point for this. And now we're going to go one step further. Find y when x equals 3. So we are going to find y using our answer to step 2. And we are going to replace x with the number 3 because it tells you to. And I'm just going to write it as a fraction because -4/3 is a fraction. So that is y equals -12 divided by 3. Y equals -4. Okay, let's do another one. Okay, so I'm going to write that as an ordered pair. -4, -16. This is x. This is y. Tells you that, right? Okay, so step 1, y equals ax. Replace y with -16, a with nothing, x with -4. -16 equals, remember you're not subtracting, it's multiplying a and x together. Divide by -4. Negative divided by negative is a positive. And a equals 4. You can even put a star by this, knowing that you're going to have to replace it into an equation. Step 2, y equals 4x. Okay, and lastly, find y when x equals 3. This is really easy math. 4 times 3, well, y equals 12. It's asking you what to find. It's asking you to find y, so you should be left with y here. Okay, and our last one. So x is 1/2, y is 3/5. Okay, so step 1, y equals, keep writing the equation over and over again and you'll know it. 3/5 is y, a is nothing, x is 1/2. Okay, so we want to multiply both sides by the reciprocal to get a by itself. So multiply this side by 2/1 and multiply that side by 2/1. So that'll give us 6/5 equals a because all that crosses out. And now in step 2, we're going to replace that a. Y equals 6/5 x. And third step, find y when x equals 3. So 6/5 times 3/1. Sometimes when students just put 3, they end up multiplying the 5 by the 3 and the 6 by the 3, which has never made sense to me why they do that. So it's always best to write a fraction next to a fraction. So y equals 18/5. And that's how you write a direct variation equation. So basically that whole front page, that's what we did. We wrote a direct variation equation. Okay, back page, we do some word problems with direct variation equations. So you don't have to just use y varies directly with x. You can do p varies directly with q, or um, s varies directly with t, and so on. The number of pages p a student can read varies directly with the amount of time t. So look how that was worded. So p is the variable that's varying directly with t. So p comes first on the left side of your equation. So I think we should write that first. P equals, again, we're used to y and x, but sometimes with real life, we want to use real life variables. We still need to put a. A is our constant of variation. So P equals a times t. The student can read 90 pages in 60 minutes. So let's write. So um, remember, T is for time, P is for the number of pages. Write an equation that relates P and T. Predict the number of pages a student can read if 90 minutes is spent reading. So other information that we know is this right here, which I'm going to underline, 90 pages in 60 minutes. So we're going to replace the number of pages with 90 and the number of minutes with 60. And we don't know A. We just don't ever know A. Once we know A, we can write our equation. So 90 equals 60 times A, divide by 60. Those cancel, the zeros cancel. You can divide top and bottom by 3, and you get 3 over 2. So 3 over 2 equals A. In step 2, we are going to replace that into our PAT equation. So P equals 3 over 2 times T. So there's part 1. And our third step is asking us predict the number of pages the student can read if 90 minutes is spent reading. So P equals 3 over 2 times 90 over 1, 90 minutes. So that is P equals 270 divided by 2. P equals 135. Write your answer and use proper units. 135 what? 135 pages. Right? Let's do another example. The cost C of going to the movies varies directly with the number N of people attending. Okay. So the cost varies directly. Whenever you see that, put the equal sign, put your constant, which is A, and then your other variable, second variable, N in this case. A group of 4 people paid $14 to go to the movies on Friday. Write an equation that relates C and N. How much would it cost for 7 people to go to the movies? Do each question one at a time. So the first part is asking you to write an equation that relates C and N. So you should have C and N showing up as an answer in part 2. Okay, so we are going to replace the cost with $14. Not going to replace A with anything, and we are going to replace N with the group of 4. Okay, that's 14 equals 4 times A, divide by 4. I'm going to divide top and bottom by 2 to get 7 over 2. So 7 over 2 equals A. Okay, in part 2, Y, oops, it's going to put Y again, so used to it that I get into the habit of doing that. So C equals 7 over 2 times N. And lastly, how much would it cost for 7 people to go to the movies? So cost is equal to 7 over 2 times 7 over 1. 7 people. So that would be cost is 49 divided by 2. Cost equals 20. Now this one you could write it as a decimal because it's asking you money question. So money is in dollars and cents. So that would be $24.50. Okay, on your worksheet you'll be asked which of the following equations are direct variation equations. Sorry. So they have to be in y equals ax form. Why or why not? So let's look at the first equation. The first equation looks like it is direct variation because this is the constant of variation. That's A, so yes, it is. The next one, and remember we need to solve for y. So let's add 7 to both sides. Divide by 3. Just divide everything by 3. I notice a lot of you just divide 2 things on the right side by 3. This is not a direct variation equation because the y-intercept is not 0. Okay. I need to go back to the first side of our notes. I just didn't put that there. Oops. So when I said A is the constant of variation, the number out here is always going to be 0 because the y-intercept is 0. So I'm going to put y-intercept is always 0. Right? So that will make this a lot easier. This right here is not 0. And that's your reason. So no, it's not. Okay. And then the last one, divide by 5. This is perfect because you could put a plus 0 at the end. So yes. Okay, so yes, no, yes. Okay, ending our notes today. Tell whether the data in the table show a direct variation. If so, write the equation relating x and y. And so what we want to do is we want to make a spot for 0 as well in our table. Let's look at our pattern, if there is one. So each of these numbers is going up by 2. So I'm putting plus 2 because it's increasing, and each of these is increasing by plus 1. Okay, let's write our direct variation equation, y equals a times x. And what we need to do is solve for a. So we want to get a by itself, so we want to divide by x. And so a equals y over x. Now let's write each of these ordered pairs as a fraction. So the first one, this right here, would be, so you put 7 on top, so 7 over 1, and that equals 7. The second one is 9 over 2, which is equal to 4.5. Next one, 11 over 3, which is equal to 3 2/3. I'm going to quit here. And the reason why I'm going to quit is these are all different. They're not equal to each other. So if these are not equal to each other, it's not a direct variation equation. So the answer is not direct variation. Different A. Let's do one where you do have a direct variation equation. So y equals ax, and divide. We didn't even really need to look at the pattern, so that was kind of pointless. They even have to put it on there because we didn't have to write an equation in slope-intercept form. So um, I go back and erase it just so it's not bothering me. There. Okay. For this one, again, divide both sides by x. So you have y over x, sorry, equals a. And now let's write each of our ratios. So the first one, put a y on top, 8 over negative 8, 4 over negative 4, 4 over negative 4. Then we have negative 8 over positive 8. And then we have negative 12 over 12. If you reduce all of these fractions, that's negative 8, negative 1, negative 1, negative 1, and negative 1. This is a direct variation equation. So yes, direct variation since a equals 1. And since we know what a equals, y equals 1 times, it's negative 1. Y equals negative 1x. That is our direct variation equation. We replace a in the y equals ax equation. So that is it for the notes today. Have a great day, Algebra 2 students.